listeners, this tutorial forms the starting point of our journey into a versatile language, that is programming in C, and it is one of the versatile languages in the high level language circles. Before we venture into the direct session on C programming and implementing the program, we have to equip ourselves with some of the very basic features of this language. Of course, you will all agree with me that in order to solve a problem using computers, human beings have to establish communication between computers through a language. We definitely need a language to communicate with computers, of course, a language which they understand. Thus, we cannot think of English for communicating with computers, but it is possible to use English-like language to work with the computers. C is English-like language because there are obvious similarity in learning English and in learning C. Okay. Before we develop, as an example, before we develop a meaningful paragraph in English, we need alphabets. We make use of alphabets in order to construct groups. Group of alphabets will come out as words, and words can be assembled to form sentences. Finally, when sentences are arranged expeditiously in a meaningful manner, in a sensible manner, then a sensible paragraph would emerge. Similarly, we can develop a workable program in C. In order to develop workable program in C, we have to search appropriate alphabets in C, and then we have to construct word-like items in C, then we have to develop sentence-like items in C, and then the sentence-like items, okay, which are called as statements in C, will culminate in a program. And this program must have been written keeping in view of a problem. Okay, it is a transformation of problem which is solvable by a computer. In order to give such a tone for the problem, it is essential that it should be converted into a program. Like English, C is also blessed with alphabets. But C, they are not called as alphabets. Instead, they are called as character set. Okay, character set in place of alphabets. And it is wrong to use the word alphabets because C has much more than an alphabet in its store. Because C language comes with more number of alphabets in its store. Table presents here. The table presents over here the kind of alphabets that is available. It is called as character set. Once again, capital letters A to Z, small letters, small a b A to Z, and decimals 0 to 9, and special characters. Okay, all of them would amount to 256 characters. Some of them are printable, some of them are non-printable, some of them are graphic, and some of them are non-graphic. Some of them can be directly used in the program, and some of them are not. Okay, and the appropriate ASCII values are also mentioned. Any typical book will give out this, but anyway, it is not essential to remember the ASCII code associated with each and every character, because without knowing this, we can do wonderful programs. And in fact, we can write a small program which can generate the character set that is present in C. Anyway, it is obvious that with 26 letters in English language, we are doing wonders. Therefore, with 256 characters, we can do much more wonderful things in using C. The 256 comes from the fact that whenever we press a character on the keyboard, it's going to generate 8-bit scan code. Therefore, 2 to the power of 8 unique characters can be framed. 2 to the power of 8 unique characters can be framed. Okay, 2 to the power of 8 minus 1, it is exactly speaking, because 0, 0, 0, 0 will also form a character. Okay, therefore, this particular first paragraph will convince us that C carries some kind of a alphabets in its store. Okay, that is called as character sets. Okay, C also has word-like items, and they could surface in the program like constants, variables, and keywords. Okay, the alphabets and digits and special characters can be tagged or can be grouped to form constants, to form variables, and to form keywords. Anyway, in construction of keywords and variables and constants, the alphabets are drawn from the character set of C. Okay, constants, as the name itself would imply, constants are the quantities that do not change during the execution of the program. For example, in the equation 2x square plus 5x plus 10 equal to 0, the numerals 2, 5 and 10 are constants, okay, and x will form to be variable. These constants can be divided into two major categories, namely the primary constants and the secondary constants. Primary constants would encompass the following, that is integer constant, real constant, string or character constant, while secondary constants would comprise of array, enumerated data types, and structures. Okay, pointers, structures, union, and enumerated data type. These are all secondary constants because they are derived out of primary constants. Okay, integer constants. A whole number is called as an integer. Integer constants do not have a decimal point. Further, an integer constant must have at least one digit, may be positive or negative. In the absence of sign, it is taken as positive. It cannot have blanks or commas in between the digits. On a 16-bit computer, okay, the available range of integer constants is minus 32, 768 to 30 plus 32, 767. This happens to be 2 to the power of 8 because an integer will consume 2 bytes. Therefore, it is 2 to the power of 16 minus 2 to the power of 16 minus 1 to plus 2 to the power of 16 minus 1. Okay. Anyway, some of the examples are 420 minus 111 minus 999 2222. Okay, these are all the valid examples of integer constants. Then real constants. Constants with decimal points. Okay, the decimal point is often called as a period. They are called as real constants. Okay, they are also called as floating point constants or numeric constants. They are called as floating points constants because the period which is present in the numerical constants of real nature can be moved to the right side or moved to the left side. They can be floated to the right side, they can be floated to the left side. If it is floated to the right side, the value of the real constant would increase, and if it is floated to the left side, the value of the constant would decrease. A real constant must have at least one digit, must have a decimal point, may be positive or negative, and in the absence of sign it is taken as positive. It must not contain blanks or commas in between the digits, may be represented. Okay, and the important thing about real constants is if the too small a real constant or too big a real constant can be represented in scientific form or exponential form. For example, 3.4 E38 means minus 3.4 into 10 to the power of minus 38 to 3.4 into 10 to the power of plus 38. Too small a value and too high a value can be represented using scientific notation, and this facility is there only with only available to real constants or floating constants. Of course, there is nothing unrealistic about integers. Integer doesn't contain decimal point, and integer arithmetic is fast, particularly integer division is fast when compared to real division involving real constants. Okay, some of the examples are quoted here: 420.56 minus 111.11, 3.1 into 10 to the power of minus 5. Okay, and minus 0.1 into 10 to the power of plus 6. Okay, the other type of constants are character constants and string constants. Any character enclosed within a single quote is called as a character constant, and any character or characters placed with double quotes is known as string constants. Okay, a character constant may be a single alphabet, single digit, or single special character placed with single quotes and has a maximum length of one character. There are some of the examples, and we may wonder where exactly these character constants are used, particularly when the program is based on some of the options expressed by the user, and some of the data types are also given in the form of a character. For example, if we are asked to enter our marital status in a program, we have to enter M for married and D for divorcee, W for widow, something like this. And if you are asked to enter the sex, M for male and F for female. And occasionally the running program may come with entry of this character constants. Supposedly there may be a situation wherein do you want to continue with the program? That may be a question. Press Y for yes and N for no. In this particular situation, we need to feed the computer with a character constant. String constants are arrangement of characters in a sequence. Okay, it is a string of characters. String, as the name itself would imply, it is a string of characters. My name is a string constant. Okay, name equal to my name. Okay, then it becomes a constant. It can have one or more than one characters bounded by double quotes. This is very important. Okay, a character constant should always be bounded by double quotes. That's how the computer recognizes. That's how the computer recognizes. Yeah. Therefore, you need to understand how exactly we can represent the character. It should be bounded by double quotes. It's a must. Can have nothing in between the quotes. Okay, if you have nothing in between the quotes, something like this, it is called as a null character. Okay, null string. Null strings are a must in a programming environment. We will come to know when we deal with string handling. Okay, it is also called an array of character constants. Okay, whose last character is null character. Okay, any character constant will always be terminated by null character. That's how computers will recognize character constants. Okay, see, the detailed things will be emphasized. Okay, whenever we discuss on string in a vivid fashion. Okay, some of the examples. This is an example of a null string, and this is an example of a fully floated string, and this is a constant. A character can also be made into a string, and it has actually two characters. This is C, and by the side of C you will have a null character. 1 and 0. Even when the input goes like this, never computer recognizes this to be a value. It will be recognized as a string. For example, whenever we want to deal with our cell numbers, there is no question of calling them an integer constant. Okay, therefore it should be taken as a string constant. A string constant is also called as a literal. Okay, let us be knowing this. Okay, a string constant is also called as a literal. 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 A string constant is called as a literal. Okay, there may be strings also in the programming environment. There may be in a particular running of the program, you may come across a string, something like please enter two values of the variables. Please enter positive integers, something like. So it may come as a guiding statement for a user. Or in the program, the following steps represent a particular algorithm. You can mention that also. Okay, so strings are used in programming environment also, particularly while programming is running, to guide the user, in order to make your programs user friendly. Okay, strings are highly used in a programming environment, whatever the language may be. So strings have acquired a place of sanctity in programming circles. Variables are the quantities that vary during the program execution. Their values will change. Basically, variable is nothing other than a name given to a memory location. It's a name given to a memory location where a particular constant is stored. If I say x equal to, say x equal to 2.5, then I am telling the computer that there is a named location called x where 2.5 is stored. 2.5 constant is stored. This is another way of understanding the variables. Okay, and probably this is the reason why very often some of the authors refer these variables as identifiers, because a variable name will always represent a memory name of the memory location where a particular constant is stored. Where a particular constant is stored. Yeah. A variable, there are some rules, okay, rules, guiding rules while we name the variable. Is the naming word for a location of a constant. It can comprise of 1 to 8 characters, digits or underscores. Theoretically, what is the length of the name, length of the variable name that can be given? Theoretically, there should not be any limit. Of course, old C permits only 8 characters, and a ANSI standard C recognizes a length of 31 characters. You please be informed about this for a variable name. But I think we cannot use 34 characters for naming the variables, because it becomes a handicap rather than becoming handy. Okay, therefore we have to give crisp names for the variables, but it is always appropriate to give the name of the variable, okay, so that we should give a sensible name for the variable, so that it will give a notion of what exactly it contains. We call sum a sum, product a product, okay, sum of the products to be sum of the products, salary a salary, serial number to be a serial number. Okay, we should stop using A, B, C, D or X, Y, Z, because they connote nothing. In fact, they may take user to some sort of a confusion state. Therefore, it is in the hands of the programmer to give meaningful names for the variables. Okay, it should have first character as an alphabet. It cannot have commas or blanks in between. It cannot have any special character other than the underscore. The compiler should be made known as to what type of constant or variable you are referring to. Okay, particularly C language dictates that the type of the variable must be declared before being used, and that is in the beginning of the program itself. We need to declare the kind of variables that may surface in the running program. That should be done beforehand. Okay, so the compiler will be made known as to what kind of variables that are being used, and so much of memory locations will be allocated, and this is called as, this typical task of declaring the variables is also called as housekeeping in programming environment. In programming circles, it is called as housekeeping. Okay, it is called as housekeeping. Right, that is to be done. Here are some examples: integer, mark, serial number, float, integer, rate, percentage, root value, character, code grade. This is a character constants, okay, character variables. These are all float variables. These are all integer variables. Okay, semicolons marked over here, okay, are placed as a rule at the end of each declaration. This is a feature of C language. Okay, we will discuss at length about this is a syntax of the language. For time being, this tutorial will only bring in some of the intricacies or some of the fundamentals, some of the preliminaries. Okay, that is to be remembered in mind, that is to be noted before we venture into some kind of a full-blown programming. Okay, while using O and L, we should be very careful. A truly awful example of disinformative names would be the use of lowercase l or uppercase 0 as variable names, especially in combination. Okay, the problem is capital 0 looks like capital O looks like 0, and small the lowercase l will look like 1. So for example, here is a variable a which is assigned to 0 1, but it looks like O and this look like L. In other way also, you cannot name a variable with using O and L because it is confusing. This problem would surface particularly while debugging the program. Okay, instructions in C. Okay, this is sentence like item in C. Okay, this is sentence like item in C. We are looking at word like items in C, that is constants and variables, and the types in constants and types in variables, and we will take on to sentence like items in C. Okay, the sentence like items in C are never called as sentences in C language, they are called as instructions in C. Okay, instructions in C is akin to sentences in English. Instructions are generated by proper use of constants, variables, characters and keywords. 4 types of instructions are recognized in C or possible in C. They are explained here. Okay, the type declaration. Okay, this instruction is to be made to give a clue to the compiler as to what type of variables are in offing or coming in the running program. Okay, and because by looking into this statement or by looking into this instruction, compiler will set aside a particular amount of memory. For example, for integers it will keep 2 bytes of memory allocated, and for floats it will reserve 4 bytes of memory. A float variable will consume 4 bytes of memory, and a long float will consume around 8 bytes of memory. Like this, a character variable will consume 1 byte of memory. Okay, anyway, before we use the variables in the running program, it is a must that it should be declared. It should be declared beforehand. Okay, right. Here is set of examples that are given. Integer, serial number I, j equal to 1. This is initialization. Okay, declaration and initialization will happen here only. Okay, by declaring the variables like this, only memory will be allocated, and the memory will contain some garbage value which has not been washed off, which has not been deleted, which might have been created by the programmer who worked in the previous session. Okay, float, root, grass salary, pi, 3.143. Okay, this is float kind of variables. Character, code is a variable of character type. It can hold only one character constant, double gamma. Okay, input and output instructions, they also look like sentences in English. Okay, the instructions perform the task of supplying data to the program and taking out the results from it and printing it on the screen. This job will be rendered by functions scanf and printf respectively. The scanf and printf are built-in functions. Okay, we need not have to scratch our head. Okay, as soon as we write this, the compiler will be able to understand as to what do we mean by scanf and what do we mean by printf. A typical scanf, of course we are going to discuss about scanf and printf in a separate tutorial. Okay, there is a lot of discussions that we have to make as to how we can write a meaningful scanf statement and meaningful printf statement. And here scanf comes something like this. This is a typical example. Okay, scanf, this function will enable the computer to read 3 integer variables. Okay, how come the computer will come to know that these three are integer variables? It is marked over here by type specifiers, data type specifiers or format specifiers. %d for this, %d for this, %d for this. D stands for decimal number. Okay, the percent printf. Okay, you have to print a statement over the screen. Then you will write like this. You will call the print function, and you will put the parenthesis, round parenthesis, and within this you will write a character string or a literal. Okay, it comes with an explanation, something like this, explanation of the answer it is throwing on the screen. The percentage mark is %f, like percentage. This is the variable which will go and sit over here in this particular location, because it is a float type variable. It will find its place over here, and these quotes will be missing when you run the program, but the percentage mark is equal to, this will surface on the screen. Okay, this will give, using this kind of statements in the printf function will increase readability of the program and also interactiveness of the program to some extent. Okay, scanf is inputting 3 variables, mark 1, mark 2, mark 3 through the keyboard. Printf is outputting the variable percentage per named as per on the screen. The input and output instructions will be explained at length in the later sessions, of course. There are arithmetic instructions or expressions. They will also look like sentences in a typical natural language. Okay, the typical arithmetic instruction or arithmetic statement, you can call it as an instruction or you can call it as a statement. Okay, an arithmetic statement will involve a left hand side and right hand side separated by equal sign. Okay, and the right hand side may contain arithmetic expression and left hand side will have a lone variable. For example, integer sum, it's a declaration, and this is an expression literally telling, okay, and 7 is assigned to A, 80 is assigned to B, here itself in the declarative statement itself. This is a Pakka statement, arithmetic statement. Sum is a lone variable which will receive upon adding A and B. A and B are the memory locations where 7 and 80 is stored. Okay, whenever expressions are written like this, okay, the computer will fetch the value of A stored in a memory location called as A, the value of B stored in memory location called as B, and it will add and it will store in another memory location called as sum. Okay, typically speaking. Okay, product equal to A star B, remainder equal to B percentage A. These are all the arithmetic operators that are being used. So we will deal at length about these operators, operands, and arithmetic expression at length in our further discussions. Okay, this particular session is intended to introduce C, the vividity of C, some of the intricacies of C, some of the pure fundamentals of C. Therefore, this tutorial is named as C Preliminaries. Okay, further, arithmetic operation of the type A plus B equal to C is prohibited. You cannot generate an arithmetic expression like this. Left hand side should always contain a lone variable. Right hand side of the arithmetic statement can only contain expression. Okay, while C is equal to A plus B is correct. Okay, arithmetic can also be performed on characters also, character x comma y, integer z, x equal to A. When you say x equal to A, you are referring to the ASCII value of A, and y equal to B. Okay, y will have ASCII value of B, and z is by the by an integer, and you are adding ASCII value of x and ASCII value of y. So ASCII value of small a, that is 95, and B 96. So what you get for z is 95 plus 96, because z is declared as an integer. If you declare z as a character, and the appropriate character will be formed, okay, you can print this character. If you print it by percentage d, you will get the integer value upon character addition, and if you just print it as a character constant, then character variable, then it will bring out an appropriate character that is designated by, which will have an ASCII value amounting to 95 plus 96. Okay, you cannot do arithmetic operations, okay, assuming that an operator is present. You can never write something like this: A dot, B dot, C, x plus y, okay, like we write in a normal notebook. Okay, so the operators are to be exclusively mentioned in order to generate a valid arithmetic statement. This is correct. This is a valid arithmetic statement with a lone variable to the left hand side and an expression to the right hand side, terminated by semicolon. Okay, terminated by semicolon. This semicolon will enforce this particular arithmetic statement to be executable. Okay, it cannot be done for exponentiation using operators. Okay, you cannot use exponentiation by using, okay, double star. Okay, it cannot be used. Okay, x equal to y, the cap 3, it cannot be used. Okay, this is used in Fortran and this is used in Pascal, but anyway, C doesn't permit, okay, exponentiation. You need to write y into 2, y comma 2. Okay, y comma 2, power function y comma 2, you have to write like that, or y into y, that is the way, y into y. You cannot write y cap 2, y cap 3, y into y, that's all. Between an integer and integer, okay, arithmetic operation between an integer and integer would always produce an integer. This is a very important point, okay, to note. Between real and real always produce result which is of real type. Between an integer and real will always produce the result which is real. Okay, operation, for example, okay, these operations are clarified in this particular table. 7 by 3, 7 is an integer, 3 is an also integer constant. 7 is an integer constant, 3 is an integer constant. 7 by 3 will never result into 2 point something. Instead, okay, it will result in 2. Okay, 2 point some, that point something will be simply vanishing, and it is called as truncation. So integer division results in truncation. Okay, instead, if you would have said 7 divided by 2, it would have given us 3.5. 7 by 2.0, either in the numerator or in the denominator we have to add this decimal point, okay, or the period. Okay, it would have given us correct answer. 7 by, this is no problem. We are mentioning decimal points or periods both for the numerator and for the denominator. Okay, 4 by 8 will result in 0, obviously, because 4 is integer, 8 is an integer constant. Okay, it should be 0 point something, really speaking, but no, it doesn't happen. 4.0 divided by 8, because this is a real value and this is an integer value, the entire expression will be converted into real. Therefore, you will get 0.5. It could be or 4 by 8.0 also, or 4.0 or 8.0, anything. Okay, control instructions are also there. They will also look like sentences or group of sentences. Okay, these instructions are written to dictate the order in which various instructions are to be executed. Okay, control statements will predicate the order in which various instructions are to be executed in a computer. It could be a sequential control construct. There is no need to develop any construct over here. You need to write executable statements one after the other. Okay, and so also the execution will also take place one after the other. If you expect a computer to execute rth statement, definitely r-1 statements would have been executed. Decision control, this will also come like a statement. Okay, it skips certain part of the program. It will take decisions depending on the conditions. Whenever we deal with conditions, okay, whenever we want to take decisions based on conditions becoming true or conditions becoming false, then we need to use decision control constructs. Okay, they also look like sentences in a typical natural language. Loop control is to be used whenever we want to make a computer to work relentlessly, iteration after iteration. For example, if you want to make a computer to write 1 to 10, possibly you have to make use of a loop control construct, which will make a computer to repeatedly do the operation of writing from 1 to 10. And if you want to make a computer to write 1 to 10 times, you have to augment loop control constructs in such a way that repetition of repetition is done. Okay, writing 1 to 10 is a repetition. Making a computer to write 1 to 10 times is a repetition of repetition. Okay, then there is another control construct called as case control construct or switch control construct. This construct will help us to execute the instructions based on integer value or character valued variable. Or I repeat, case control construct or switch control construct is also another construct which is available like a sentence, demanding sentence of course, which executes instructions based on an integer variable and character variable receiving many values, and depending on the value it receives, we should execute certain statements. Okay, these things will be explained. Of course, this tutorial has no intent to deliberate on these kind of statements, but anyway, as an introduction, these things are mentioned. Okay, there are some points to be remembered as basic fundamentals of C. Okay, the following are the invalid names of the variables, because what? It cannot be a variable because there is a question mark over here. And 0 cannot be used for naming a variable because it is a numeral. SINT, there is a gap here. INT is a keyword. Okay, it's a reserved word. We cannot use that. Following are the invalid statements because float is a keyword. Name equal to RAM. No, it should be given to double quotes. Okay, RAM is a character string. Therefore, it should be starting with double quote and ending with double quote. LML. Okay, Okay, LML is the variable name. Of course, there is no space. Let us say B into D into D double star is there. Double star cannot be used. Okay, BD cube by 12. Okay, that is a formula. Anyway, D cube cannot be stated like this. It should be D into D into D. If A dot into B dot into C, A plus B is algebraic expression, then its equivalent C expression is A star, B star, C star into A plus B. If I is an integer variable and R is a real variable, this is what happens. I equal to 3 by 8 will essentially give you 0, and 3 over 8.0 will also essentially give you 0, because the variable which is receiving this expression, the aftermath of expression after calculation, is an integer. It becomes 0. 8 by 3 will give us only 2, because the other part of the answer will be truncated, because this is a typically integer division. Okay, if R is real and these expressions will produce R equal to 3 by 8. 3 is an integer, 8 is an integer, and it should give us 0, but when it is assigned to R, which is declared as a float, it becomes 0.00000, whether we like it or not. If you make it as 3.0 divided by 8, it will give us 0.375. If it is 8 by 3, it will give us 8 by 3 integer by integer division. It is actually 2. Since it is assigned to R, which is a real variable, it becomes 2 point followed by 6 zeros. Okay. If I is an integer and R is a real variable, and if we write I equal to 8.5 and R equal to 85, then what is being stored in I is 8 and in R is 85.00006 zeros. Okay. Type of table data types and ranges. Okay, this will explain. A character can be represented between the numbers minus 128 to 127, because a character will consume 8 bits and 2 to the power of 7 minus 1. Characters can be exactly represented. A character will consume 1 byte of memory, that is 8 bytes. Small short integer or integer, it varies between the value of an integer. A short integer can store is from minus 32,768 to positive 32,767, because a short integer will consume 2 bytes. 2 bytes means 16 bits. 2 to the power of 16 minus 1 happens to be 32,768. Okay, long integer would consume 4 bytes and it is 2 to the power of 32. 2 to the power of 32 happens to be this much. Okay, there is no need to mug up all these things, but we should have a feeling for this figure, and we should also know the extent of values a particular data type can store. Because let us say if you are trying to find out 15 factorial, and if you have declared this number which carries the factorial answer to be a short integer, and we are going to receive negative answers, because 15 factorial will be blown out of proportions, and it should require a long int category, because 15 factorial happens to be exceeding this particular value, therefore unable to hold this huge amount of value, what is called as overflow occurs. So it is in the hands of the programmer to declare the variable appropriately. Okay, and he or she as a programmer should also have some kind of should be knowledgeable about the possible extent of answers he or she may receive upon the program executing correctly. Okay, C is a middle level language because it stands between high level languages like Fortran, Basic and Pascal, and you should be knowing that Unix operating system has been written using C. Okay, C compiler has been written using C. Okay, some of the machine languages, assembly language has been generated using C. Therefore, it stands as low level language also and middle level language also. Okay, it serves the purpose of high level language also. The high comes from the fact that it is English like, that's all. Why C is called as an high level language? The emphatic answer is because it looks like English. Okay, it is English like. Okay, C can be used on MS-DOS, Unix and Xenix operating system. This you know, all these things. Okay, there are 32 keywords available in C, only 32 keywords. Okay, the table gives all the possible keywords. Okay, they will be used, they are preset in the language library, and they connote a different meaning. Okay, they should be used appropriately. Auto, break, case. Okay, these are all the listings. There is no need to remember this also, but you should be knowledgeable. Okay, whenever we tend to name a variable, it is necessary that we will not draw the names of the variables from this keywords, and there is no dearth also, okay, while naming the variable. And we have agreed that we will name the variables to an extent where we should give a notion of what exactly it contains, and while we name the variables, it is better we adopt what is called as Hungarian style, that is the industry standards. Okay, and we need to represent by Hungarian method. Okay, let us say salary amount, if you want to write lives. Okay, salary. Okay, I think this should be small letter. Salary, it is a small letter, SALARY, salary. Amount, A is capital. Okay, but anyway, we should make it very succinct, and it's better we name the variable names in a short variable name, but connoting what exactly it contains. Because if we venture into long variable names, if it is a program of technical kind, okay, if this variable were to appear several places, okay, the expressions tend to be very big, and it may be confusing also. Okay, and there are some delimiters, okay, which will give some kind of a meaning for some of the, okay, processing elements of C. Okay, hash is called as a preprocessor directive. Comma is used in variable list separation. Semicolon, of course, it will attach some kind of a executableness. Okay, any statement which is delimited by semicolon is executable. Colon is there, it is used for labels. Okay, we will make use of all these things. Okay, anyway, being a preliminary tutorial, I think these things cannot miss our attention. Parenthesis, okay, used in C expressions. Square bracket used to represent arrays. Curly braces used to demarcate blocks of C instructions. Okay, and there are library functions, arithmetic functions readily available in C. ABS, actually this is small a. Okay, of course C is case sensitive. We should be using anything that comes from the language should start with small letters. Okay, C, cos function, cosine of an angle, absolute value of an integer. Cos hyperbolic function. Okay, exp raises the exponential e to the 10th power. Okay, fabs, that is absolute value of a float variable. It returns absolute value of a float variable. ABS returns only absolute value of an integer variable. Okay, fmod, absolute value of a floating point remainder. Okay, calculate hypotenuse of a right angle triangle. Log, calculates natural logarithm. Log 10 calculates base 10. Okay, mod, okay, breaks down argument into integer and fractional parts. Okay, power, okay, calculates the power of a number. It's a function, of course. Sine of an angle. Sine h, hyperbolic sine. Square root of a number. Tangent of an angle. Tan h, that is calculates hyperbolic tangent. Okay, with this I think we have introduced the very much fundamentals in C with some intricate point. Therefore this tutorial is titled as C Preliminaries. Okay, we will take on to in a proficiently increasing manner. We will just take up chapter by chapter, okay, in a proficiently increasing manner, and we will deal with all the intricacies available in C. Okay, and we have made up our mind to bring out this programming in C just like a course. And my respected listeners should know that C is offered as a course. C is a course subject. Okay, thank you.